All right, and we are back for another day of working with logarithms. Hope you guys have been doing well. I've had a lot of time to read lately. Read the Graveyard Book by Neil Gaiman. Another good book that I just finished was something called The Unwilling by Kelly Broffett or Brafett. Not sure exactly how to pronounce it, but a wonderful book, fantasy book. And then I just started another fantasy series, epic fantasy series, The Shadow of What Was Lost by James Illington, or Islington. All right, but so finding some time to read. I'm very, very happy that I managed to go to the library and I picked up like a stack of like 6, 7, 8 books. Brought them home right before they closed the libraries with all this. So got this nice stack of books that I'm working my way through. Hopefully, you're finding time to do some things that you enjoy and having some fun, catching up on Netflix, Hulu, maybe some reading, those kind of things. So, but that's not why we are here today. We are here today to talk about the wonderful and exciting properties of logarithms. All right, now, once again, the properties of logarithms are connected to our properties of exponentials. All right, and hopefully you'll see a little bit of that as we work through our lesson today. So just to kind of get you into the swing of things, if you look at those openers, we've got three problems, 1A, 1B, and 1C right there that work with said properties of exponents. So once you simplify those three expressions for me, think a little bit about exponents, and we'll come back and talk about how those relate to logarithms. All right, so let me flip over here to my work for the opener. All right, and we know that when we multiply two things with the same base, the property of exponents is that we add the exponents. So I have 4x's, 6x's, 2x's, so I'm multiplying 12x's total, right? I have 7y's, 9y's, so I'm multiplying 16y's total. Now, when I move to 1b, all right, this is the power to a power property, right? This says I have 7 groups of 4. Well, if I have 7 groups of 4, I have 28 x's that I'm multiplying, right? I have 7 groups of 6. Well, if I have 7 groups of 6, I have 42 y's that we are multiplying together. And then 1c, all right, so if this is the product property, this is the power to a power property, this is the quotient property, all right, in which says we can subtract our exponents, right? And so 5 minus 3 is 2. 15 minus 10 is 5. And we look at where there are the most x's or the most y's to know whether that result stays in the numerator or stays in the denominator. I have more x's in the numerator, so my x squared is in the numerator. I have more y's in the denominator, so that difference stays in the denominator. So those are really the three basic properties of exponents, which once again are just really shortcuts for multiplication. All right, so now as we think about that, let's talk about how that ties in, all right, to our properties of logarithms, right? And so let's look at our first rule of logarithms, and it's called the produce rule. Oh, did not catch that. It's not the produce rule. We do proofread and we try to catch these things. It's not the produce rule, it is the product rule. All right, so not the produce rule. I don't know. Is that, eat your greens, eat some vegetables, apple a day keeps the doctor away, something like that? Is that the produce rule? I don't know. Maybe that's another fancy rule in higher mathematics. But the product rule is what we're talking about. And what this says is if we have logarithm of some base and we have a product in the argument, and that's what we call this right here. We call this the argument. Then we can rewrite this as the sum. So log base b of m plus log base b of n. Now, to help you kind of see that, what's really happening here, if we look at what we have here and look at it in terms of something that we might be familiar with, we have log base 5 and 5 times 25. If we apply the product rule, that would be log base 5 plus log base 5 of 25. Now, what power of 5 gives us 5? 1. What power of 5 gives us 25? 2. So we really end up with 1 plus 2 over here, which is 3, right? Now, if I go back here, 5 times 125 is, or it's going to be 5 times 25 is 125, right? All right. And so 5 to what power is 125 would be 3. So you can see that it works out. And what's really happening here is we're adding those exponents because remember, log base 5 of 5 is an exponent, right? Log base 5 of 25 is an exponent, right? So remember, the result of that logarithm is the exponent. So really what we're doing is we're adding those exponents, much like what you did up here, all right? And what we're doing today is what we call expanding logarithms, all right, and using these properties to expand them. And there's different reasons why we expand and what we're going to talk about in the next lesson, which is condensing, all right. And some of that gets into what you want to do in calculus. By expanding, things become a little bit easier sometimes to take derivatives or to integrate, things like that. Sometimes when we condense, it makes things easier to solve. So as you work through mathematics over the next 2 or 3 years, you'll see right how some of these properties of logarithms will benefit you, not necessarily in and of themselves, but it will make the math that you're trying to do to a logarithm simpler for you in the long run. All right, so what we're always looking for is the product within this parenthesis here, within the argument. So when I look at 2a here, I can see I have the natural log of 8 times x. Well, that allows me to break that apart. All right, so I can rewrite this as the natural log of 8 plus the natural log of x. And then that's all I need to do. Now, what I do want to do is kind of look at each piece once I've used the product rule to separate and see if I can simplify. And there's not really much simplification we can do here. All right, so when I look at 2b, all right, it's log base 4 of x times y. All right, so that means I can separate this into log base 4 of x plus log base 4 of y. And then once again, when I look at each piece, there's not much simplifying to do on 2b here. Log base 4 of x is just that. There's nothing we can simplify. All right, so I would like you to try 2c. It's a little tricky, couple small things in there that we'll talk about, but give it a shot, see how you do. All right, so let's see. Now, notice we have 3 things multiplied, right? And so the product rule, just like we had 3 things multiplied here and we could add all 3 exponents here, it carries over to what we do here. So if we have a product of 3 things, we can break it into 3 pieces. So we'd have the log of 100, and I apologize, my system is slowing down here, plus the log of x plus the log of y. All right, now notice so that was the first kind of little trick, is that we don't care how many things we're multiplying, right? We can just write out each thing that we're multiplying, right? So if we have 3 things multiplied here, we're going to end up with 3 logarithms. If we had 8 things multiplied in our argument, we'd end up with 8 logarithms. Now, here's the simplification part. Nothing we can do with log y, nothing we can do of log x, but log of 100 we can simplify, because now remember, this is the common log, this is base 10, so 10 to what power gives us 100? And the answer is 2. So we can simplify this piece down to 2, all right? And then we can just bring down everything else, and that's all we can really do to this problem, all right? And that would be our final answer. So if you get to a logarithm that you can simplify, we just want to go ahead and write it as whatever value it is within the context of that problem. All right, and so then there's our final answer right there. Okay, so now let's look at our second rule, which is the quotient rule, right? And then once again, we had the, all right, product rule, all right, for exponents. We had the product rule for logarithms. We had a quotient rule in 1c, all right, for exponents. We have a similar quotient rule for, all right, for logarithms. That's going to mimic what we did with exponentials. Now, once again, kind of using what we know here, right? So log base 5 of 125, that's 3, right? Log base 5 of 5 is 1, right? And 3 minus 1 would be 2. Okay, now if I come back over here and look at the division here, I get 125 divided by 5, which would be 25. All right, and then what power of 5 is 25? This is also 2. So you can see how the left side and the right side are correlating to each other. And once again, just like we would have subtracted those exponents up here, all right, we're doing the same thing here. So what that means is that when we have a quotient in the argument, all right, when I have a quotient in the argument, I can rewrite it as a subtraction problem. All right, so log base b of m minus log base b of n. Okay, so now let's look at 3a here. I'm just going to switch colors, give us a little bit of variety here. And let's look at 3a. I'm going to scroll a little bit here just so it's a little higher on my screen. All right, so once again, we see that we have a quotient, so I can break this into a subtraction problem. So log base 7, all right, of 49 minus log base 7 of z. Now, once again, once I've broken it into its pieces, I want to look at each individual piece and see if there's any simplification I can do. And what we have here is log base 7 of 49. What power is that? That is a 2. So I can simplify that guy down. So 2 minus log base 7, all right, of z. And there's my final answer. All right, so once again here, why don't you do 3b here? All right, see if you can do that one real quick. Because I want to talk a little bit about 3c together to make sure you pick up on some subtle detail there. So try 3b real quick. Okay, hopefully you saw that 3b was very much like 3a here. We have a quotient right here, right? So I'm going to rewrite this as log base 3 of 10 minus, all right, log base 3 of x. And notice I have log base 3 of 10, but that's not an easy simplification. That's not an exact number like 3 or 5 or 1/2 or something like that. So we would just leave it like so. All right, so now let's look at 3c. And I wanted to look at 3c together because we were going to have to use a combination of the quotient rule and the product rule. And I wanted to make sure you kind of saw the order in which to do that. So the first thing is we want to take care of the major operation within the argument, within those parentheses. And that major operation is the quotient. So we want to use the quotient rule first. All right, so when I look at this, I'm going to use the quotient rule to write out log base 9. And I have to take the entire numerator here, which is 81x. Okay, and then minus the entire denominator. So log base 9 of the entire denominator, which is y and z. Okay, so notice that that is the quotient rule. And now this kind of gets into what we were just saying. Like once I've used one rule, I want to look at what's left and what simplification can I do. All right, and so what we see now is now when I look at this piece, I have a product. All right, so I have 81 times x. In much the same way up here, we had 8 times x. So I now want to go right into, all right, simplifying this and seeing what I can do with my product rule. Okay, so log, try that again. So log base 9 of 81, all right, plus log base x minus log base 9 of y. Now notice, all right, because this is subtraction, everything that I have over here when I separate it will also be a negative. So normally this would be a positive here because I do log base 9 of y and then log base 9 plus z. But I'm really going to distribute that negative to both pieces here. So then that's going to be minus, all right, log, all right, base 9 of z. All right. Now, once again, then I have to look again. No, nothing to simplify here. Nothing to simplify here. Nothing to simplify here. But now when I get here, and I left my base 9 off of this one, so let me squeeze that base 9 in there. All right. Log base 9 of 81. Well, what is log base 9 of 81? That is 2. And just because I'm running out of room here, I'm just going to quickly just erase this part right here. And because we know what that is equivalent to. No, not up there. Oh, my system is not responding at all right now. So let me hit undo here. Hopefully that will undo that. Thank you. I'm going to pause real quick, erase that, and then come back. All right. So apologize for that. My system is really slowing down right here with everybody at home here. My wife already works from home, and my kids, like you guys, are doing homeschooling too. So they're on the internet. So things just going to get bogged down from time to time. So I apologize for that. So, excuse me. So you can see that there's our final result. Okay, now let's talk about the final property here, which is the power rule. All right. So when we do the power rule, once again, we're looking for the argument, right? Whatever's in these parentheses to be raised to a power, and then we can bring that power out front and multiply, all right, by that a value, all right, which was the power here, which is exactly what we did in the opener with that power to power property. All right, so if I look right here, log base 5 of 25 is 2, right? And then 4 times 2 would be 8. So this is 8 over here, right? So now if I looked right here, right, this is 5 squared. Well, 5 squared raised to the 4th power would be 5 to the 8th power. Well, what power of 5 would give us 5 to the 8th? It would be 8. So you can see that some of the properties that we have really are just, once again, the same thing that you would do with exponents. All right, and then once again, once you've done one property, you just want to take your time, all right, and check and see if another property can be applied or simplification can happen. So let's look at 4a. So we have the natural log of y to the 5th. All right, natural log of y to the 5th. So that means I can take this power and I can bring it out front, right? So I can do 5 and then times the natural log of y. And there's nothing else I can do. All right, nothing else that you can simplify. Now, once again, we're looking for just the argument to be raised to a power, not the entire thing. All right, so and I'll just write this real quick here on this next page here. So notice, all right, so if I had the natural log of y and the whole thing, right, was raised to the power of 5, there's nothing I can do, right? So the whole thing is raised to the power of 5, not the individual argument. Right, so we're looking for this piece, whatever we're taking the log of, to be raised to the power. All right, so let me go back to our notes here. All right, and so now when we look at 4b, maybe if I can scroll down here. All right, so notice that power there, all right, on 4b, all right, we have the argument raised to the power of 3. So I'm going to take that 3 out front, so that's going to be 3 log of y times z. All right. Now, notice, now I have a product within that. So now I need to use the product property on that. Now, typically what you do is once you have this number outside, we can just leave that 3 setting outside, open some parentheses, and apply our next property. So then log, all right, of y plus log of z. And if you want, you can just leave this 3 out front like this, or you can go through and distribute to each thing inside your parentheses once you've applied that property, whichever way you want. It's all good. All right, and we'll go from there. All right, so here's what I would like you to do. I'd like you to try 4c here. All right, so simplify that and see how you do, and then turn the video back on, and we'll check in and see how that went. All right, so let's see how you did. So I went ahead and worked 4c on a separate sheet here, just so I didn't run out of room here. All right, so hopefully you started with the power property, and you took that 5 and dropped it out front. And then now, once I reevaluate what I have right here, right, I have a product. So now I can break this apart. Now, once again, I left the 5 out front, so I'd have log base 4 of 64 plus log base 4 of z. Then once again, I'm going to look at each piece. Can I simplify? Can I apply another rule? So when I look at log base 4 of 64, right, that is something I can simplify because that is 4 to the 3rd power is 64. So I can make that a 3. Can't do anything to that. And then once again, if you would like, you can distribute to both terms. You can leave it like that. Any equivalent form is acceptable. All right. So that's really the properties of the logarithms that you'll need to know. And as you hopefully have seen, all right, they're just a consequence, right, an extension of what you already know about, okay, exponents. Now, and I mentioned this earlier, but we call this expanding logarithms, all right? And so when we're taking them and applying these properties in this way, we are expanding logarithms. The next lesson, we'll just do the opposite, and we'll condense logarithms. So now let's look at a few more problems that are a little bit more complicated, all right, and require you to apply multiple, all right, properties within each problem. So I'm going to start with number 5 here. All right, and what I'm going to do is look at this and notice, all right, and we said this, that we have to apply the property that the major operator, right? And so right now, notice the major operator is multiplication, not the power, because if it was the power, it'd be on the outside. All right, so I need to separate this first before I can get to those powers, right? Because they're different powers. They don't have the same power. So if I use that product property, I'd have log base 10, right, or the common log, or just log of x squared, plus, all right, log of y to the 6th. And now that I have these broken apart, right, now what I can do is apply the power rule to this one. So I can take the 2, all right, move that power out front, and I'd have 2, all right, log of x, all right, plus, and then now I can move the power here. So I can take this 6 and move it out front, 6, and then just log of, and I apologize because this is like super slow here, all right, of y. Okay. And then that's our final answer. Nothing else. All right, we can simplify here. All right, so now let's look at problem 6 here. Okay, and once again, we have to look at what is the overall property? What is the one thing that we have to do first? All right, so now for number 6, the overall property, right, is really the quotient. So we need to use the quotient property first. So now if I break that up based on the quotient property, I'm going to have natural log, and I'm going to have the cube root of x minus, all right, and not a good, minus, oh no, I didn't really want to erase everything. All right, so let's try that again. And man, this is really slowing. And now it's trying to go somewhere else. All right, so let me pause the video here and try to get everything back in line. All right, so I managed to line everything back up, and I went ahead and wrote out the quotient property here. So we have the natural log of the cube root of x minus the natural log of 6y to the 4th. Now, for some of you, you may not realize this, but every root, square root, cube root, whatever it is really a power. All right, and so the cube root of x, all right, so anytime you have the cube root, maybe, anytime I have the cube root of x, I can rewrite that as a power. And the power I can rewrite that as is x to the 1/3 power. So this is really a power problem. All right, if you have the square root of x, all right, maybe, all right, that can be rewritten as a power as well. And that power is the 1/2 power. All right, so that's the square root. So the key to this is that I need to recognize that this is really now a power problem, right? Just like this is x squared, I can take that 2 out front. This is really x to the 1/3. So I can take that 1/3 out front. So I can have 1/3 natural log of x. Now, before I do this, before I can get to this power, I have a product. So you have to do the overriding property first, which is product. So I need to separate these two. Now remember, these are both behind the subtraction sign, so that's going to be natural log of 6 minus the natural log of y to the 4th. All right? And so now, nothing else I can do with the first part, so I can just bring that 1/3 natural log of x down. All right, minus the natural log of 6. And now I can get to my power property here, and I can bring that 4, all right, out front like that. And then that takes care of, all right, our problem there. All right, so here's what I'd like you to do. All right, I'd like you to give 7, 8, and 9 a shot on your own. I'm going to give you a couple of hints here. So see how this is all taking the square root of? Remember what I just talked about, that the square root is the 1/2 power. All right, same thing here. So give those 3 problems a shot. All right, do those on your own. And then once again, you can either check your work with the Fully Worked notes online, or you can flip the video back on and we'll go through them together. All right, so now I have everything worked. I'm going to flip over to the work for these 3 problems so we can kind of go through them together. Now, so this is what I was talking about with that power. So this is really to the 1/2 power. So what I want to do, that would be if the whole thing is raised to a power, we want to take that power out front. So that square root is really the 1/2 power, so I took the 1/2 out front. Now, when I look here, My overriding property is the product property. I have a product of three things. So I want to break those three things apart. Now, once again, I'm going to leave that 1/2 out front. So I'm going to have log base 6 of x to the 8th plus log base 6 of x to the 7th plus log base 6 of z to the 12th. And now as I evaluate each piece here, I can see that I can apply the power property, all right, for a second time within this problem to each individual thing. So I can take that 8 and move it out front, 8 times log base 6 of x. Take the 7 out front, 7 log base of y. Take the 12 out, 12 log base 6 of 7. Now, once again, you could leave it like this if you want to distribute the 1/2 to everything. Totally fine. Any which way, it's all good. All right, so let's take a look at problems 8 and 9. Now, when I look at 8, the overriding property that I have to take care of first is the quotient. All right, so I'm going to have log base 2 of x to the 4th times the square root of x squared plus 3 minus log base, I left my 2 off of that, so let me add, I think I dropped my 2's in some of these problems here. So let me add the 2 here. All right, okay. All right, so I've got those added back now. All right, and then log base 2 of x minus 4 to the 5th power. Now, once again, as I evaluate each piece, I have to see what property takes precedence. So when I look at this piece, what takes precedent is the product. I have x to the 4th times the square root of x squared plus 3, so we have to apply our product property. So log base 2 of x to the 4th plus log base 2 of the square root of x plus 3. Now, when I evaluate this, what property takes precedent? It's the power property, because I have this argument raised to the power of 5, so I can take that 5 out front, and I get log base 2 of x minus 4. Now, once again, now I go back and reevaluate each piece. So when I look at this, what property takes precedent? It's that power property. So I take that 4 out front, 4 log base 2 of x. Now, once again, this is really raised to the 1/2 power. The square root is the 1/2 power. So I can take that square root out front of 1 as 1/2 times log base 2 of x squared plus 3. Nothing else I can do to this one, so I bring it down. Now, notice this has x squared in it, but I can't do anything because it's not multiplication here or division, right? So if I have x squared plus 3, there's nothing else I can do. So if this argument consists of addition or subtraction like it does in the first or second part and the third part here, there's nothing else I can do. There's nothing else I can break apart. All right, now, number 9 was a little bit tricky. So my guess is most of you did natural log of x squared plus 3x minus 10 minus the natural log of x squared plus 8x plus 15 by applying our quotient property. But so yeah, you got to factor this, because if I factor this, I create a product. All right. So notice, and I didn't show the work for this, but if you factor x squared plus 3x minus 10, it factors into x plus 5 times x minus 2. If you factor x squared plus 8x plus 15, it factors into x plus 5 times x plus 3. So by factoring, we create a product. And by creating the product, then we can now apply the product property. And I would get the natural log of x plus 5 plus the natural log of x minus 2. And then once again, I'm subtracting both things here. So I'd have minus the natural log of x plus 5 minus the natural log of x plus 3. And notice what happens now. This allows us to simplify, right? Because now I have the natural log of x plus 5 minus the natural log of x plus 5, which is 0. And that leaves us the natural log of x minus 2 minus the natural log of x plus 3. And there we are, my friends. There's your properties of logarithms. All right, it's time for us to sign off. Sorry that this ran a little long, all right, with my computer system slowing down and things like that. But that takes us to the end of this lesson. All right, have a great day. Go out and get some sunshine. Go for a run. Go for a bike ride. All right, and I will see you next time.